Good afternoon, dear student, and welcome to this 17th edition of our Numerical Method 2 class. So, as I said a while ago, before the recording, I was saying that today's class might not be long. I'm not feeling well. I'm just let me the class. So I asked her to cancel the class, but I say, okay, no, let me have the class. But anyway, we'll see how things will go. Welcome to all of you. Camilo, I think you are going to lead us today. How many of you did the problem that I asked you to do yesterday? The first one is done, huh? Because I gave you the expression of bk. When k is an even function, we saw that bk will be 0, right? It is in the slide, huh? It's in the slide, so there's nothing to be done about that one because it's already there. As you can see here, for the first case, where f of x is 1, on the interval 0 pi. Okay, that function is not there. I didn't plot this one. Okay, no, it's here. It's here. This one in blue. This one. So for this function in blue, this is the bk. When k is even, all the bk's are 0. When k is odd, the bk's are given by this. You just substitute that in the expansion, this one. So that will be, you can replace k with p first, and p will run from 0 to 1. So it will still be the same with p, and then k will be 2p minus 1. And you get this expression also. And now that p you can change and relabel pk. It's the same thing. K is a dummy variable. You can change this k to any variable you want. So if it is p, I can relabel pk. So it's exactly the same thing. So that one is done. So Camilo, you have the floor. So how did you compute this? What did you get? What is your result of bk?
I got, must I just say the result?
Okay, let me open the new window, and then you will, you can tell us what you obtain, and the other student will confirm if they get the same, if they obtain exactly the same result. Yes, can you tell us what you got? Okay, let me write your result in blue here. Yes, what did you get?
I got my bk is 4 over pi multiplied by k to the power of 3.
Multiplied by k to?
No. The pi is the one multiplied by k to the power of 3.
Like this?
Yes. Then the whole thing multiplied by -1 to the power of k.
Like this?
Yes.
And what is the range of your k? Is k equal to 1, 2, up to infinity?
Yes.
Who else obtained exactly the same result? Or a different one? Guy, I'm listening to you. Please participate to make the process easy. Say something. Jonas.
Say I didn't go till the final answer.
Kashopi. Kashopi. Mujende, you are just joining us. You are
Yes.
late.
Okay.
Similarly for Salomo, who also joined us. Sindile, are you with us? Or is your ghost? Not your ghost. Let's say your picture. Sindile,
So
what did you get? On your profile picture, you are there like a boss, whereas you are not a boss. And you are fooling people as if you work hard. But you cannot even answer my question. People will sit and say, wow, that girl, wow, that one, yeah, she's steady. She can work at NASA, huh? Wow, she can even contribute to launch satellite into space. Hey, the way she's concentrated there, wow. She will do wonders. Okay, contribute now. We'll know whether you are really hardworking or not. Okay, so what did you get? Mujende, no, not Mujende, Sindile. Mbwere.
I didn't finish.
Really? Okay, you didn't finish. Where did you stop? Tell me what you wrote. Okay, tell me. Okay, first step. What did you do? From here, what did you write? You did not finish. Okay, tell us. What are your steps? So from here, what did you do? The test is next week, eh? If you are behaving this way, I'm scared, eh? I'm really scared. I'm scared for you. This power of K. Okay, that's fine. Who wants to contribute? So you are trying to tell me that you did not. Nanuna, class red, tell us what did you do? Class rep. Simeon, you joined late. Is the class rep with us? Or she's hiding behind a camera? Class rep. You should be leading by example, huh? Now, who wants to tell us what he did? He or she. Who want to share? Who wants to share with us the details of his or her computations? Who wants to share? Ehrenfried? Frida?
I didn't do it, doctor.
Why? Were you sick?
No, doctor.
So how can you explain you didn't do what I asked you to do? Are you proud of yourself?
No, doctor.
So what's the problem? Yes, you wanted to say you don't understand what?
Fourier series.
What don't you understand in Fourier series? We cover enough videos on the subject. We did some example in class. Yesterday we did other example, and today we are still talking about that. What exactly you don't understand? Might also help the other student. What exactly don't you understand? Fourier series is a formula. You have an expression. That series S sub f of x, expressed as you know, is the Fourier series of the function f. Now, if you are asked to find the Fourier expansion or the Fourier series, you use that formula. The only thing you need to find are the AKs and the BKs. That's all. And now we have theorem to tell you when the AKs are 0 or the BKs are 0. That is whether the function is even or odd. If the function is neither even nor odd, so both AKs and BKs will be present in the expansion. And those AKs and BKs are just integrals. You have to integrate the function f of x times cosine kx or sine kx, depending on whether you are computing AK or BKs. So that boils down to integration by part or integration to. That's all. You did integrals in calculus 2. You pass calculus 2 to be here, so you know integration. So what else don't you understand? And if you look at all the examples, that's exactly how we proceeded. Function is given. Function is periodic. Period. We say we'll be dealing with period function whose period are 2 pi. And that's what we said. So all our functions, the period is 2 pi. I wanted to give you the formula when the period is not 2 pi. It will confuse you all the more if you are struggling with just a single period. So you just need to know the formula, that's all. And I indicated how you can remember the formula. They are not complicated. So after a class, you are supposed to go through the example, read the notes or watch the video and try to redo the problem. Like this one I gave you yesterday, you say you didn't do. Most of you did not even do. How will you understand something when you don't even attempt? The computation, just integration. There's nothing else. There's nothing magical. You write the formula, you look at the information or the data about, the information about the function, and then try to understand which formula to use. Kashupi, you didn't say anything. What did you get? Kashupi, I'm listening to you. Kashupi. Class rep, you haven't said anything. Simeon, which expression of BK did you get for the second function? Where f of g of x, I call it g of x equal to x squared. For x in the interval 0 pi. And we said that the function, we take the function to be an odd function. If the function is assumed to be an odd function, or by construction, the function is an odd function, after the theorem, the last theorem we stated says that if the function is odd, all the AKs will be 0. We know that. Because if your function is odd, it can only be expanded in terms of an odd function. That is sine, only in terms of sine. If your function is odd, cosine cannot be present because cosine is even. But now, if the function is even, sine cannot be present in the expansion. It will only be cosine. So the A case will be non-zero and all the B case will be 0. Now, if the function is neither odd nor even, so both A case and B case will be non-zero. It has to be clear, and these are the things you need to remember. So understanding the notes, first of all, the theory, you need to understand that theory. The general expansion has cosine, and let me go back to the notes. anyway, it depends. This is the expression here. This is sine sub f of x. That is the series, Fourier series of the function f, right? By definition, this is the general formula. The general formula that you can write for an arbitrary function is this one. Now you look at the function. If the function is, like in this case, the function is odd here, that is structurally, that is when you look at the function, the structure of the function tells you, because you can see that the function is defined here between negative pi and pi. You can see that for positive, it will be positive, for negative, it will be negative, like here. If you take f of negative x, you see that negative will be here. So this is an odd function. But because it's an odd function, if you compute a case and b case, you will see that a case will be 0. We did that for in the previous example before the theorem. Before we tackled the theorem, we computed the a case and we found that the a case were 0. And after I say that, if we use the theorem, there will be no need for us to compute the a case. So that's the first thing. Now, if your function is just 2 pi periodic and it is neither odd nor even, then your a case and your b case will be non-zeros. You will compute both a case and b case. And this is the formula for AK. AK is given by this formula. 1 by pi, the integral from negative pi to pi. For BK is 1 by pi, the integral. Okay, and then the integrand for AK is f of x cosine kx dx. And for BK, it is f of x sine kx dx. So you compute both a case and b case when your function is an arbitrary function, meaning that it is neither odd nor even. Then you can compute both. You don't use, you don't set the a case or the b case to 0 without even computing, right? When you have an arbitrary function. But if the function is constructed, or you are given a function with the information that the function is odd or even, don't even calculate the other coefficient that would be 0. Just set that coefficient to 0 after the theorem that we stated. So you can see that for this function that we know that it's an odd function, when we compute the a case, that all the a case turn out to be 0. That's when you compute without taking into account the parity of the function. This is what you get. But if you take into account the new information that we have, that if your function is odd, the a case are 0. So all this computation is a waste of time. You don't perform all this computation for AK. Just set AK equal to 0 because the function is an odd function. And then for the BK, you can just compute BK directly, right? So you will not need to integrate from negative pi to pi because the function is an odd function. You can just integrate from 0 to pi and then it will be 2 times here in front. You get exactly the same result. And these are all the explanations. So these explanations are for you to understand the theorem, because I explained all these. These explanations were given so that you understand why in the theorem you are told that the a case are 0, the b case are 0, depending on whether the function is odd or even. And now, for the factor of 2 that comes in the a case and b case when you compute, I explained the same thing here. Now you see we start with the formula that we know, and this is transformed into 2 by pi, the integral from 0 to pi. So this formula is only valid when your function is odd or even. If you have a problem with this 2 by pi integral from 0 to pi, then use the integral from negative pi to pi. But if your function is given only in the interval 0, pi, it's not given on the interval negative pi to 0, then you cannot use this one. You can only use this one when it's defined from negative pi to pi, when you have those information. But if the function is only given from 0 to pi, you have to convert it and use this one. You can see, like in this case, it's given from negative pi to pi, so you can use the full range from negative pi to pi. You can use that. But if you know that it is even or odd, you can still split that interval into 2 and use the other one. Is that clear for everybody? Is that clear? Is it clear for everybody?
Yes, doctor.
Yes, Simeon? Are you saying something? Okay, so Katuo, you will tell me, you will guide me, tell me. Okay, let's try to integrate the first time this thing. And I want you, Katuo, to tell me. So this is the coefficient bk that we want to compute for the function f of x equal to x squared when x is in the interval 0 pi. So this is how you will compute your bk. So how do you perform integration by part to this? I'm listening. How do you perform the integration by part?
Let u be equal to x squared.
Beg your pardon?
I'll hate to be a lecturer.
Yes, Simeon, you say something? Go ahead. If you want, you can even isolate this 2 by pi. You can forget about it. Just isolate that out of the integral, and you just consider this one. The integral from that. And then we have our x squared here, sine ks dx. Yes, so how do you proceed? Yes, Simeon, I'm listening to you. You said something. Integration by part. So even integration by part, is it a problem?
No, sir.
Yes. Tell me what I should do. I'm listening.
What? You let x squared to be your u, and that would be your dv.
Okay. So in that case, what would that become if we apply integration by part to the term in bracket, in the curly bracket? So here we apply integration by part. So that would be what? uv from 0 to pi minus what?
V du.
Good. Okay, so now we need to know, okay, we know u already, we need v. So from this one, what is our v? So what is v? This is dv. What is v?
Is it not negative cos kx over k?
Okay, you can write this because your k starts from 1. So you can divide, right? K cannot be 0 here. So since it starts from 1, no problem, you can do that. And the next thing here, we need du, right? Du. So what is du?
Two x.
2x. Isn't that wrong? If you say,
2x dx.
very good, 2x dx. Okay, so once we have this, we just substitute in that expression. So we have 2 by pi uv. So uv will be negative x squared cosine kx by k from here. And we evaluate it from 0 to pi. Now we have that minus the integral from 0 to pi v. So v, that this v, you see that v is negative. So this negative with that negative become plus, so I can change that. Right? So cosine kx by k into this 2x dx. Okay, so for now, I can leave this without evaluating. I can leave this for now. We are not in a hurry, right, to simplify this expression. Now, if you look at this, you can see that from the previous one, the factor of x was raised to the power of 2. We lower the factor of the power of x by 2. Now, if we proceed further, you will see that we'll be able to eliminate this x the next time, right? And the third time, we will just integrate directly. So it's up to us. Either we take this factor 2 by k out of the integral and perform the integration by part to x cosine kx, or we can keep this to be our u. Okay, let's re-express. It's up to us to decide. It's up to us. We can do that, or we can keep all the factors there and proceed. It doesn't change anything, right? So we have here negative x squared cosine kx by k, and then we integrate from 0 to pi. So what I was saying is that we can rearrange this. We can rearrange this. We can rearrange this. Either we take this 2 by k out and perform our integration by pi, or we can just call all this, that is 2x or 2 by kx. We can call that our u, and this one our dv. So it's up to us, cosine kx dx. So this time we can call this again. This expression, all this. If you don't want to take 2 by k out of the integral, you can just call that u, and this dv. Right? You can do that. It's up to you. You are free to do whatever you want. Take it. The method is not unique, or the approach is not unique. It's the same. Okay, now if you do that, so this is our u, this is our. Okay, so we can compute that directly. So let's come here. So this will be equal to what? 2 by pi. You can keep that. Okay, now we have plus. So we have our uv. So what is uv? uv. So we have u, which is 2 by k x. And now from this one, what will be our v? It will be sine kx by k, right? So that will be our v. If you differentiate this, it will give you that. You can always check, right? Once you write your v or whatsoever, you can differentiate to make sure that there's no error. If you differentiate sine kx, it will be k cosine x. That k with the denominator will cancel out, you get that. So it's correct. Now, if you want, you can group this together with that and write it k squared. It doesn't matter. It doesn't matter at all. Okay. Now, that is the integral from what? 0 to pi. So later on, we can group these two, this one and that one, we can group if you want, right? So minus the integral from 0 to pi, what? V du, right? V du. So this is our v. So our v is sine kx by k so that is our v, because this is u, this is v. We copy that v here times du. This is our u, and what is du? It is 2 by k dx. right? So that is the expression, right? Now we can collect all these terms and factor. You see that we are left with a single integral, right? So let's rewrite this. So this will be equal to 2 by pi Okay, so this we can collect all these and put together, right? So we can put all that together. We can put it here on in parentheses. So we have, so this will be 2x. So we can even write it here. 2x, right? This 2x sine kx, right? Okay, now this one we can multiply this by k to reduce both to the same denominator k squared. So we multiply here by k, numerator and denominator by k. So this will be negative k x squared cosine kx by k squared. See? By k squared. And this is evaluated from 0 to pi. So we put these two together here. And then this last integral, which is negative, I can take this 2 by k squared. As you can see, 2 by k squared. And then integral from 0 to pi. Now what do we have inside? The integrand will be sine kx dx. You see. Still, if I want, I can take all these k square. You see here we have k square, k square. I can factor by k square and take it out there. Right? It's still okay. It doesn't hurt anybody. Okay, so finally, let us, okay, let us, okay, so I will take this k square out of the integral. I mean, out of this curly bracket. So here we have 2 by pi k square Okay, so now this will be what? 2x sine kx minus kx square cosine kx. And this is evaluated from 0 to pi, right? I took this kr already, so we are left here with negative 2. This negative 2 because the k square has been taken out here. Okay, now the integral, remember that the integral, this one, I can integrate that, so the antiderivative will be negative cosine kx by k. So that negative with this one become positive, right? And here we have cosine kx by k. Of course, that is from 0 to pi. So if you differentiate this, you get this, right? Because if you differentiate cosine, it becomes negative sign. And that negative will be this negative. And then the k We cancel out with the denominator to get that. So you can always check, always. There's no excuse for you not to get the right answer. Right. Now, at this stage, we can just perform the substitution. Is evaluated at pi minus at 0. So when x is equal to pi, or yeah, if you substitute x equal to pi, I go inside here. That will be for the first one. For this one, for the sign, it will be k pi. So this will always be 0 for k pi, right? This will always be 0. And also at 0, this will also be 0. So the sign, the contribution of sign will always be 0. I could have even done that above, but it doesn't matter. It doesn't hurt anyone. So this one will be 0 always at pi and at 0, because remember, any factor, any integer factor of pi is 0, right? Because k takes a value 1, 2, 3, 4. So sine of pi, when k is 1, sine of pi is 0. Sine of 2 pi is 0. Sine of 3 pi, 4, so this will always be 0. So I don't need to substitute. I can already see that for these two values. If I substitute, this contribution will be 0. So I'm done with that part. Right, I'm done with that part. Now, if I come to this second one, to this contribution, first, when now if I want even, if I want, I can even at this stage. Okay, I cannot group. Okay, because of this, I could have grouped the two, but it's fine. Now, when x is pi, I substitute there. You see, we get negative. Right, negative. You can see this negative. So we have negative k. X is pi, so k pi square cosine k pi for this. Now minus, this will be 0. Okay, now when x is 0, it will cancel out that term, right? When x will be 0, this entire term will be 0. So this is the only contribution for this expression. Now we move to the next one, this one, plus this is 2 by k. 2 by k. Now the substitution. Cosine k pi, right? Minus cosine of 0, which is 1, right? When x is 0, I put there, that will be 1. So this is what we have at this stage, right? But I'm not done. I need to simplify this. So this one, two by k, 2 by pi k square. Now here inside, what is this? This is negative 1, right? This one, cosine, this just this term. Is negative 1 k. Now with this other negative, it will be negative 1 k plus 1, right? So I can write here, and similarly this one also. this one. Right. So I can write this. I can substitute. So that will be k into -1 to the k plus 1 with this other negative, right? You will increment that k to +1. There's a pi squared. This one I did not include that one. So that's what we have for this term, and then the second term plus 2 by k, right? So we have this expression, -1 to the k minus 1. So that's the expression, the entire expression. Now, at this stage, you can see that we can discuss now. Because you can see that when k is not really necessary for us even to discuss, because this one will, okay, when k is odd, no, even, this part will go, because this will be negative. No, this will be 1. If k is even, this will be 1, and that one will go. But still, we will get an expression here that does not cancel out. And now when it will be odd, this will be -2, and still this will still remain, right? So we can just write the final expansion in terms of k. We don't need to distinguish. Everything is there, so we can just keep this one. We can keep this. But if we want to factor, by k again, this will be k squared, right? If you want to factor by k. So what I mean is, if you want, we can write that this is 2 by pi k cube. And then here we can write k pi square, or k square pi square -1 k plus 1 like this, plus 2 into this expression, right? You can simplify the way you want. It's not compulsory to do that this way. So -1 to the k minus 1. So this is our bk. We just substitute in our expansion, right? So this is bk. So you can see that your result was not correct, because if you look at what you computed there and this one, they are completely different. Okay, but I don't think we made a mistake anywhere. Check the computations, right? Make sure you check the computation. Okay, so if we agree that everything is fine, that there's no computation error, then you write your gk, that function that so you say that your gx will be equal to what? This is the bk, so summation. K starting from 1 to infinity. Then you carry this entire expression, right? Or if you want, you can take this 2 by pi, you can write it out here. So this is a factor you can take. It does not depend on k. That is 2 by pi. This one you can leave it there. Now this k cube, k to the cube, we can take it inside, or we can leave it there. So we can say it is 1 k cubed, and then we substitute all this entire expression. That is k square pi square -1 to the k plus 1 plus 2 into -1 to the k minus 1, like this, into sine kx. So that is our expansion. This is the final result. This is the expansion. So redo all the computations to make sure that you get exactly the same thing. And if there's an error, let me know. Okay, I think we'll stop here. That's all for today. Is there any question, any concern before we close? Okay, so far so good. If there's no question, we'll stop here. Thank you for your kind attention. God bless you and see you tomorrow. I will let you know tomorrow we have a class tomorrow at 8:30. I'm not sure, but if I don't feel well, I will inform the class representative about tomorrow. But anyway, I will still record even if it is after 8:30. If at 8:30 I'm not I'm not comfortable, I will ask the class representative to inform you, and the class will be recorded later on. Okay, that's the end. Thank you. God bless you and see you tomorrow by the grace of God. Bye-bye.